Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 5 from the October-November 2023 Mechanics M1 paper from Cambridge. This is paper 4, variant 3 from the 9709 syllabus. This question here is about statics. We have a light string AB is fixed at A, has a particle of weight 80 newtons attached at B. Horizontal force of P, magnitude P, is applied at B such that the string makes an angle of theta with to the vertical as shown in the diagram. It's given that P is equal to 32 newtons. Okay, and the system is in equilibrium. Find the tension in the string and the value of theta. So you're going to have a tension in this string here, which is going to act, if we're looking at the forces acting on the particle, it's going to act in that direction. And we need to find the tension in the string and the value of theta. So what we're going to do is we're going to try to resolve these forces horizontally and vertically. That seems a sensible thing to do. So what I'm going to do is I'm going to draw some lines here to help us. So I'll draw that line over there. I'll also draw a line over here. Okay, now what I can see from this is that this angle here is theta, because that's vertical, and they're alternate angles. Let me make like this Z shape. So that angle is theta. So now if I take this diagram and I resolve the forces vertically and horizontally. So vertically, it's in equilibrium, so the upward forces equal the downward forces. And if I want to resolve this force, this tension, which is acting at an angle, let me just draw it so that it makes it clear. The tension is acting in this direction. If I want to resolve the tension in this direction, then I'm going to have to go into the angle given. Okay, I'm going to have to go into the angle given, and this red dotted kind of arrow represents the component of the tension in the vertical direction. You're going into the angle you're going to use, it's going to be T times cosine theta. And if I want to resolve the force in this direction here, which is horizontally, okay, then we're going to be going away from the angle given, because the angle given is theta here. We're going to go away from it, so it's going to be T times, we'll use sine for going away from the angle. It's like, if we compare it to this, we're trying to find here the adjacent side, and here we're trying to find the opposite side. Okay, so adjacent side we use cosine, opposite side you use sine. Or going into the angle you use cosine, going away from the angle given you use sine. Okay, so if we resolve vertically, then we can say T times cosine of theta is equal to 80 newtons. Okay, and if we resolve horizontally, we can say T times the sine of theta is equal to 32. Now, a lot of students here, they didn't know what to do next. They see that we have two unknowns, theta and t, but how do we deal with it? Now, we have to go back to what we understood in, the easiest way is to go back to what we understood from P1 trigonometry, that we know that the ratio of sine theta over cosine theta is equal to the tangent of theta. So if I call this equation 1 and equation 2, if I take equation 2 and I divide it by equation 1, the t's will be eliminated, and I'll be left with tan theta equals 32 over 80. Okay, so if I divide these two equations, I end up with t sine theta equals 32, and I'll divide it by that, so I'll have over t cosine theta, and that will be divided by 80. So that's dividing equation 2 by equation 1, and that leads us to the t's being cancelled. You're left with tan of theta is equal to 32 over 80. So then we can find what theta is by using inverse tan of 32 over 80. Which gives us 21.81801, 21.801 degrees. Don't round prematurely. Okay, keep this answer in this form, but do write it to one decimal place for an angle at this stage. So that's the answer for theta. But we've written this down in some more accurate form. We have it in our calculator in some more accurate form. That will help us to now find what t is. So we can use now either of these two equations to find what t is. So I can say t is equal to, for example, 32 over the sine of 21.801. And I will use it in its more accurate form so I don't lose accuracy in my answer. So this is going to be 32 over the sine of the angle, which is the answer in our calculator. All right, so that's the more exact form of the answer. And that gives us 86.162. 86.162. All right, so therefore we can say the tension is equal to 86.2 newtons. And there we have our answer to this question. That's the tension of the string and the value of theta. So that's part A of this question answered. Right, so now for part B, it says here, it is given instead that the tension in the string is 120 newtons. So we know the tension in the string now is 120. Okay, and the particle attached to B still has a weight of 80 newtons. Find the value of P and the value of theta. So now we can do a very similar thing. We can resolve the forces horizontally and vertically. Okay, with this tension. So we've got the component in this direction and also in this direction. So we know that this angle here is theta, which we have to find again. We don't know what it is now. It's changed. The situation is changed. So this is now, instead of t, this is 120 times cosine of theta. And this is 120 times sine of theta. So again, we can resolve vertically and horizontally. So if we go horizontally, for example, vertically first, we can say that we got 120 times cosine theta is equal to 80. And horizontally, we can say that 120 times the sine of theta is equal to P. Okay, so it's pretty simple now. We can find what theta is by just using this equation. Okay, we can say that cosine of theta is equal to 80 over 120. So therefore we can say theta is equal to, so inverse cosine of 80 over 120. That gives us 48.189. So therefore theta is equal to 48.2 degrees. So that's one of our answers. And then we can find what P is by simply using the fact that P is 120 times the sine of 48.189. Okay, so we can just do 120 times the sine of the angle given. So 120 times the sine of the last answer. And that will give us the answer for P, which is 89.442. 89.442 goes on. So therefore we can say P is equal to 89.4 newtons. Now, many people, what they did is they took the answer of this, they put 48.2. Okay, and you can see the answer comes as 89.5. Now you will lose a mark for this. So always use the more accurate form of your answer. So what I did is I used the answer in my calculator, or if I use this as, for example, even if it's to one more decimal place, so 48.19, okay, if I round it to one more decimal place than needed, and then use that in the answer, you'll see that it will give me the correct answer when it's rounded 89.4. So 89.5 should lose you 1 mark, even though you did everything correct, because you used a value of theta which is, rounded. Okay, you have to use a higher degree of accuracy than required in your final answer in your intermediate steps. Okay, so don't use the value of theta you found, use the value of theta before it was rounded in the next step. That's very important, and you will lose marks for this if you do that in the real exam. It's very important for you to not throw away marks. Okay, And so that's something important for us to realize in this topic. Okay, so in general, in just even in P1, M1, whatever you're doing, it's important for us to realize that. So that concludes this question, which is question number 3, I think. No, actually, it's question number 5 I'm talking about. Question number 5 from this October-November 2023 paper. Other questions from this paper can be found in the playlist that will be linked over here when you see the end of the video. Other questions from this topic of statics can be found in the playlist that will appear over there. You can subscribe to my channel by clicking on this link. And in fact, what I'll put here is another playlist for my Cambridge, for my edXL material, which is dealing with statics, to look at different examples of questions. And you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.